All right, welcome to the introduction to combinations. In this video, I'm going to start by introducing you to the concept of a combination. Then we'll look at the equation that we can use to solve combination problems. And finally, we will apply this new understanding to a fairly straightforward combination example. Now, so far in our exploration of combinatorics, we've really only explored situations where we were counting the number of ways that we could possibly arrange or line up objects, and order was always an issue. Now, what if order doesn't matter? Or what if we simply just want to group or combine objects together? In this case, we will create what's called a combination. So for example, maybe I want to choose a team of 3 people out of 5 possible people who've tried out. Or maybe I'm going to choose 3 menu items to create a meal at a fast food restaurant where there's 30 items up on the big board. In this case, order really doesn't matter. I'm just creating a group or choosing the objects out of all of the possibilities. When we calculate the number of possible combinations, we use this equation. So it's NCR equals n factorial divided by r factorial multiplied by the difference between n and r factorial. I like to read NCR as n choose r. N still represents the total number of objects that we have to choose from, and r represents the number of objects that we will select or combine or choose to be in a group. Now you might notice that this equation looks very similar to our permutations equation. Essentially, all that's happened here is I've divided by an extra r factorial. And what I'm doing is I'm eliminating the permutations that are the same combinations. Let's dig into that a little bit further. So if I had a combination of a burger, fries, and a shake from McDonald's, that's one possible combination to make a meal. I could also reorder those to say I would like a shake, fries, and a burger. That's the same combination of items, however, it's a different permutation. All right, let's dig into an example. It says, a restaurant serves 10 flavors of ice cream. Danielle has ordered a large sundae with 3 scoops of ice cream. If each of her scoops is a different flavor, they want to know how many different ice cream combinations that Danielle could make. So just as per usual, let's start by identifying our total number of objects. So in this case, we have 10 possible flavors to choose from. And that means that n is going to be equal to 10. We are going to choose 3 of those flavors to create an ice cream sundae combination. So r is going to be equal to 3. We will begin by writing out this new equation for NCR, so that's equal to n factorial divided by r factorial multiplied by the difference of n and r factorial. Then we can plug in what we know, so we know n is equal to 10 and r is equal to 3. If we simplify our equation a little bit here, we'll see that we've got 10 factorial over 3 factorial times 7 factorial. Again, we'll start by writing out some factors to see if we can make any cancellations here. So I'm multiplying 10 by 9 by 7 factorial, and I'm going to stop there because I can see that I can cancel that out with the 7 factorial on the bottom. So when I do my cancellations and simplify a little bit further, I end up with 10 times 9 times 8, all divided by 6, which leaves me with 120 possible combinations of ice cream. Now that sounds delicious. Well, that brings us to the end of our introduction to combinations. So in this video, we talked about the concept of a combination and that order does not matter when we're counting the possibilities. And secondly, we learned our new formula to calculate the number of combinations, where we were choosing R objects from a total of n possible objects available.